All right, this is the very last example, example 6, social science forgetting. Okay, in a psychological experiment, students were shown a set of nonsense syllables such as POK, RIZ, DEQ, and so on, and asked to recall them every minute thereafter. So what will happen? They will remember less and less and less as time goes, right? We're going to forget about them. These are nonsense syllables. So the percentage of R of T who retained the syllable after T minutes was found to be given by the logarithmic learning model. R of T equals, let me highlight this. This looks like something that we will be using. So this will give us the percentage who retained the syllable. Okay? So if everybody remembers it, it's going to be 100. But will everybody really remember it? What's the highest R here, guys? I can see from the picture, the graph, and the vertical asymptote. I'm sorry, I was teaching pre-calc all day today. So not vertical asymptote, but vertical axis is percentage of students retaining the syllable. So unfortunately, there is not a single time that everybody remembered it. There's no graph on the 100, okay? Some people forgot. So the highest percentage is 80, I can see. And it's going down and down and down, right? You see the curve is going down as the time goes. And about 14 minutes, like not many people remember it. How many people, what percentage of the people remember it? Like 10%-ish remembers it. Everybody forgot. Okay, so what are we doing with this function now? And let's look at the domain. They said t is in between 1 to the left and 15 to the right. What does that mean? So they only started measuring after 1 minute. Okay, so the time they waited 1 minute, and they took the measurement at 1, 2, 3, 4, and just keeps going on. And they waited until 15 minutes. Okay, and I don't really see that graph here, but they did say it goes up to 15. It shouldn't probably have an error, probably end right here. Okay. Alrighty, so what are we doing here? What percentage of students retain the syllable after 1 minute? Hello, here is 1 right here. And I can clearly see that 80% retained. Hey, but maybe we should use the equation because they gave it to us. So what is R of 1? If you plug in 1 into the function, you will get 80 minus 27 times natural log of 1. And do you guys remember what natural log of 1 is? That's 0. So it is 80. But I didn't need to plug it in. I could read from the graph right here that when x is 1, or I'm sorry, shouldn't call it x, the time is 1 minute. Okay, the percentage was 80 by just reading the graph, right? But hey, we use the function, so that's good. All right, let's keep going. Part B. Find R prime of t. Okay, and explain what it means. So first of all, we need to find R prime of t. Let me write down R of t here so that we can take the derivative right below it. I have 80 minus 27 natural log of t. It's an easy function. All right, so what is going to be R prime of t? Now, I will take derivative of each of these at a time. So, for example, what is d dt of 80? And then I will do minus what is the derivative of d dt of 27 natural log of t. Okay? What's that going to be? Let's see. Well, derivative of a constant, that is just going to be 0, right? So that's 0. And what I can do is I can pull out this 20, not 20, but 27 to the front and have 27 just waiting for it outside. And I can really just take the derivative of natural log of t, which is just 1 over x, right? So this is pretty nice. Let's keep going. I don't have to write the 0 minus, but I'll write down negative 27 And the derivative of natural log of t is 1 over t. So my final answer is this, -27 divided by t. So that is my r prime of t. Now what do they want? They want us to find r prime of 2. So let's plug in. So r prime of 2 is -27 divided by 2, which is -13.5. I don't know, guys. I'm crazy nowadays. So I don't know if I can divide things by half. It's probably wrong and I should be embarrassed. Oh, hey, it's right. It's right. Oh, God. Okay, so what? How about the unit? Let's put some unit on this. So -13.5 syllable. Can I say words or syllables? What was the unit they used? Syllables. Okay, syllables. Syllables. Syllables per minute. You okay? So that's the unit. And the fact that this is negative number means that it's going down. It's going down. So let's see. And I did type it. The results indicate that blank minutes after, well, 2 minutes after, right? Because 2 is the number that we plugged in. 2 minutes after, students have been shown the syllables, the percentage of them. Oh, okay. I'm wrong. And I don't want to re-record this, crap. It's not percentage, sorry. It's not syllables, it's the percentage points. It is -13.5 percentage point. I'm out of room. The percentage of them who retain the syllable is decreasing. Why am I say decreasing? Because it's negative. It's decreasing at the rate of 13.5% per minute. So when I said -13.5 syllables per minute, I was wrong because the y value, it was the percentage of students, remembering, not the number of syllables, the syllables. So sorry about that, but I'm so glad I got this typed up here. All right, the very last part. What will the percentage of students, when will the percentage of students who retain the syllable drop to 20%? So what they want is, when is r of t equal to 20? And wouldn't we be able to just read it from the graph? 20% is right here. And if I extend my line, my horizontal line straight to the right to see where the graph is, I would say the answer is somewhere in between 10 and 11. But since that is not accurate, I better solve this. So let's solve this. So what was r of t? I go back up and copy it. Wasn't it like 80 minus 27 natural log of t? 27 natural log of t. So plug in 20 into the other side. We'll do 80 minus 27 natural log of t. First, subtract 80 from both sides. You get -60 equals -27 times natural log of t. Divide both sides by -27, you guys. We should be able to simplify that fraction then. Let me just use another piece of paper over here. Why not? Fraction will turn into positive, and both are divisible by 3. So I will divide them by 3 and get 20 over 9. Okay? And that equals natural log of t. Okay? In order to solve for t, now I will write this in exponential form. Because this is natural log, base is e, and the power is 20 over 9. I'm about to plug this into my calculator to see what decimal we will get. How long will it take for people to forget so that only 20% of the students remember those syllables. Okay, so I'm over here and I want to type in e to the 20 over 9. E to the 20 over 9 is 9.23 minutes. And I thought it was in between 10 and 11. So this is when I go back and double check. Is my answer, or I'm sorry, is my line straight enough? Who knows, maybe my line was not straight enough. That's why my number came out a little bit wrong. But I'm going to try to squeeze this into the single page so that I don't have to give you guys a 6-page document. Let me go and see. Because my algebra work, when I solved this by hand, I got 9.23 minutes. I don't know, maybe my line was, because I think my math was right. I don't think my math was wrong. So if I try again, draw a straight line from 20. There's gotta be a straight line tool in this thingy, but this is as straight as I can. I still think it should be like around 10. So what I will do is, who knows, maybe the graph is wrong. But what I will do is I will check the textbook to make sure, because I think this is another textbook example. But I am gonna go ahead and upload this video. So here is the very last page and you are done with section 2.3.